You must be wondering, why am I asking about quadratic equations and complex numbers? You'll get to know very shortly how they are connected. Okay. I want you to find the roots of this equation, which is x square minus 2x plus 4. Okay.
Oh, the roots?
The roots. You understand what are roots for this equation?
Yeah.
What is it?
So it'll be x, and then 2. What's the root of minus 2x? That's just...
Roots of the equation means you need to find out the value for x.
Yeah. Oh, okay, that way.
That way, yes. When I say roots, that means you're supposed to find out the roots of this. I mean, the value for x.
I just do it, this equals to 0, and then I find it, right?
What equals to 0?
The quadratic equation.
Quadratic equations equals to 0. Okay, so let's do it together. So what do you want to do? Let's do it together. X square minus 2x plus 4 equals to 0. That's what you'll do.
Yeah.
After that, what's the next step?
Split the middle term.
Split the middle term. All right. Are you able to split the middle term here?
I don't know. I haven't done.
You're not able to, isn't it? Are you able to? Just check. Take your time. We're exploring something here.
No, we can't.
You can't. Reason? Why we can't?
Because if we split the middle term, 1 times 1 doesn't equal 4.
Yeah. So I think we have 4. We have to find the factors for 4. And the factors would be either 1 into 4 or 2 into 2.
2 into 2.
And I need a plus. I need a plus 4 and a minus 2. And using these two or these two, I'll not be able to split the middle.
Yeah.
So this process is out of question for us. Okay. So if we can't do this, then what is the other way out? Is there any other way out that we have learned before?
I have to check my book on side.
Sorry?
I'm just checking my book.
Okay. Is there a quadratic formula? Have we learned something called as quadratic formula?
Are you talking about ax square plus bx plus c equals 0?
That is the standard equation of a quadratic equation, standard form. Ax square plus bx plus c, that's the standard form. Quadratic formula was x is equal to minus b plus minus.
That one.
Right.
Minus b plus minus and then root.
Under root of b on 2a. Okay.
Yeah.
So in this case, we have to find out. See, I always tell my students to find out A, B, C, D. What are the 4 things that we need to find out? A, B, C, D. When you're using quadratic formula. So what is A?
1.
Compare this equation with the equation that I have.
Yeah, that part is easy. So A is 1, B is minus 2, and C is 4.
B is minus 2. C is, what 4. Did you say C is? C is 4. And D has a formula. So D is B square minus 4.
Minus 4AC.
You know what is D called as? D is the discriminant. What is it? And D is going to play a very important role here. What is it?
Yeah,
it's a discriminant.
I remember doing this formula. I just didn't remember it until we started seeing.
That's okay. So B is minus 2. You put a square minus 4. A is 1. So I'll plug in 1 here. So
just B
is 4.
Minus 12.
It is how much?
Minus 12.
4 minus 16, which is equal to minus 12. So D, you got minus 12, right?
Yeah.
Now I'm going to plug in all of these values here.
In a calculator.
1 second. Yeah. So in the formula.
2 plus, so just be 2 plus minus root minus 12 over 4.
Yes. X is
over 2.
Minus 2 plus minus under root minus 12 upon 2, and a is 1, so upon 2, right? So that
Yeah.
becomes 2 plus minus under root of
Minus 12.
minus 12, right? Plus minus means these are the two answers.
Yeah.
One is with a plus, another
One is with a plus and one is with a minus.
But we are stuck here. Till grade 10, what we were doing is, if you get this kind of an answer, what is the problem in this answer? There's a problem here. What is the problem in this answer?
Minus 12 is in a perfect root, or like you can't have a root of a negative number.
Root of a negative number, all right? Now there is the story behind this. That's the problem here. So you know who's,
Yeah,
what is
this was the one question I got wrong in the logs as well.
Okay.
Because like inside in the log itself, you can't have a negative number for x. So there was like a whole debate.
Yes.
Because there's this one quadratic equation for logs.
Yeah. Yes. So you understood the problem in this, right?
Yeah.
So now, exactly similar situation. There's a mathematician. His name was Heron. Okay. So you know what was his finding? Any idea? What did Heron tell us about?
No, miss.
Finding the area of a triangle, which is like this.
Up into base into height.
But I don't have the height. I have to find the area of this triangle. I don't have the height. I just have the three sides. And it's a huge field. It's an agricultural field. How will you find the area if you don't have the height? So what to do? So Heron gave us a formula, but in one situation, he got stuck in this kind of a situation where he got under root of negative number and he could not figure out aage kya karna hai, what to do now. All right. So after that, there was another mathematician who came up with a solution to this. All right. And the solution was a completely new system, a completely new number system. So till now, if you remember, I'm going to relate this again with a quadratic graph. Do you know how a quadratic graph looks like?
Yeah, it's a parabola.
It's a parabola. All right. I'm going to draw three things here. Okay. Three graphs. This. Okay. Three situations for us. Okay. One situation, the graph is looking like this. Okay. Second situation, my graph looks like this. And the third situation, my graph looks like this. Okay. What is it? What is the difference between the three?
Y-axis.
Y-axis? Is it Y-axis or X-axis?
It will be Y-axis only.
Y-axis as in, can you elaborate? What do you mean to say Y-axis?
Vertical translation is different.
Are you sure? Is it translation or it's telling us something else?
The point of each graph is different.
How many points are being cut here?
Oh, the two x-intercepts, and then there's...
So there are two x-intercepts in the first case. All right. Remember this, okay? How many x values? Two solutions, two roots. Okay, I asked you to find...
And those should usually be the answers in your quadratic equation, right?
Right. What about this one? So there'll be two answers, right?
There's only one in that one.
How many answers?
One.
Only one answer, so one root.
And in that there's zero.
Huh?
Zero.
No roots. No roots. Right? That's what we learned last year. This is what up till here we have learned last year. This is a case when your discriminant is greater than zero. So the under root part is a positive number. Greater than zero means it's a positive number.
Positive number.
Here, D is equal to zero.
D is zero.
Right? And in this case, D is less than zero, which means it's a negative number. Right? It's negative.
Yeah.
So that's when you say that we do not have any real solutions for this particular equation. No real solution. And we used to skip this part till grade 10. But now we have to find an answer using complex numbers. All right. Okay. So now complex numbers tells us how to find the value for this. Okay. Had this been under root of 12, it was okay for us. It was easy. But this is, since it
Yeah.
is not, it's not a positive number. It's finding the solution is a little difficult. And we are in the third situation here. With this, we are in this situation. So the answer for this lies in complex numbers. Are you getting it?
Yeah.
Okay. All right. So now I'm going to start with what complex numbers are. Okay. So you understood, as I told you, that whenever we are finding complex numbers, such numbers will have a solution now. All right.
Yeah.
So for us in complex numbers, this under root of -1 will be written as I. Okay. So the number system is now divided in two parts, the entire number system. One is called as the real numbers. The second part, which we are learning
Imaginary
now,
number.
is the imaginary numbers. All right. So now we are learning a completely new system, which is imaginary numbers. Now in imaginary numbers, under root of -1 will be represented as I. Okay. So what will happen if I square it? If I do I square, it will
just
become
become -1.
Absolutely perfect. So let's go to this. Coming back to the question that we were doing. How can I write this in terms of I? Let's write this in terms of I. Okay.
-12i or 12i.
Okay. So I can write it as 12i under root of 12, and there's an I. So what I'll do is I'll break it. Okay. Let me just break this part. How will I break it? Let's see. This is 2 plus minus. Can I write this as 12 into -1 under root?
Yeah.
Right. Which means I can write the 12 as under root of 12 into under root of -1.
Yeah.
So 2 plus minus under root of 12 and under root of -1. This is something we learned in surd.
Okay. And then it can just become I.
And now this,
I square.
yes, absolutely. Now this becomes I. This whole thing becomes I. And upon 2 is as it is. All right. So what are we doing here? And then you know how to find under root of 12.
Yeah.
Right. So this whole thing becomes, how do we find under root of 12?
I don't use a method. I just use a calculator if it's not a perfect.
Okay. So otherwise, what we do is root 4 into 3. I can write it like this. Under root of 4 into 3. Under root of 4 into under root of 3. Under root of 4 becomes 2. Root 3. So I can write root 12.
Okay, that way.
Surds, in terms of surds.
Surds. I forgot we did surds.
Right. So 2 plus minus 2 root 3 I. Understood?
I
want 2.
Okay.
Got it? Right. And now you can obviously cancel out the 2's because the 2's can be a common thing.
Yeah.
My two answers are, this becomes 1 plus minus root 3 I. That's my answer. Got it? Yeah. Now the answer for this, I could only figure out if I knew complex numbers. Till grade 10, we never knew what is a complex number, so we could never figure it out. All right. So such cases is what we are going to deal with when we are learning complex numbers, right? Quadratic equation, the third type, when D is less than 0. I hope this part is clear to us.
Yeah.
So now I have a few questions for you. Can you tell me how do I write this?
That one will be 3i. Right?
Right.
8i.
8i.
11i.
11i. Let's do H.
H. 6i. No, minus 6i.
Minus 6i. Okay, let's do this.
Which one?
F.
17. Oh, F. 17 is a prime number, so I don't know how to do it.
So can we find out the root of 17? We can leave it as under root of 17. Or we can plug in, we can put it in the calculator and get the value. Otherwise, how can I break it? I can break it as root 17 into root -1. Into root minus
1.
Right? And this becomes 17i. Under root of 17.
Okay.
Root 17i. But I doesn't have an under root. I separate. Got it?
Yeah.
Yeah. So you
Some people
understand?
mess that up when they write the quadratic, or like
Uh-huh.
just any, when they write any root, they sort of overextend sometimes.
Sorry, I didn't get you. Sorry.
I'm saying that when you're speaking, sometimes you might overextend what's supposed to be in the root and what's not.
Huh, huh. So are you getting this point? Is this clear?
Yeah.
How we can represent these numbers with I?
Yeah.
Okay. All right. So now,
How would you do cube roots?
cube roots like
Like, for example, it was cube root -8.
cube root of -8. Okay. So in cube, so see, I is only for minus square root. We don't do cube roots with this. What we can do is, if I do minus one, this whole thing square is equal to I square. So this becomes, what is the value for this?
Or
-1 is I
I
square.
square.
If I do cube of this, then what will get? What will I get?
I
Under root
cube
-1, under root -1,
on
under root
minus
right?
1
That's cube root,
equals
right? Which is I cube. So what's the value?
cube.
This becomes, multiply these two, it becomes -1 and under root of -1, which is how
-1.
much? I. So can I just write it as
It
minus
is.
I is equal to I cube? That's how you keep figuring out.
Oh, okay. Yeah, that makes sense.
Got it? That's, but then every time it will be either in terms of, so we can, it'll be either in terms of -1, 1, or I.
Yeah.
You always end
Only
up with
only the coefficient will be different.
right. So got this point?
Yeah.
Perfect. All right. So now if I ask you to figure out the roots of a quadratic equation, can you figure it out?
Yeah.
So let's do this. I want you to do on your own. 3a.
A.
3a.
Okay. I think I got it.
What is the answer that you got? Final answer.
5 plus minus 4i.
5 plus minus, okay. 5.
How's it? Oh yeah, 2i. Never mind.
2i.
Is it? No, I got 4i.
Is it? Let's check.
Because I got d as -16.
Okay. So A is 1,
1
B -10,
-10,
C
29.
29, and D is
100 minus 116.
4 A C. All right. So which is 100 minus 29 into 4.
116.
Okay.
Oh wait, yeah, I forgot to divide it by 2. Never mind. I forgot to divide by 2. That's right.
Okay. You got your mistake? Understood?
Yeah, I forgot to divide 4i by 2.
Okay. So are you getting 5 plus minus 2i?
Yeah, now I did.
Very
I
good.
just forgot to divide 4i by 2.
Okay.
So I just left as is.
So got this
Yeah.
answer. So you know how,
Yeah.
if we get a quadratic equation, and if we have the third case where the discriminant is less than 0, we have to solve such cases using imaginary numbers, right?
Yeah.
Okay, perfect. So Now we move to the next point.
Okay.
See, now if you look at this, these imaginary numbers will always come with a y, well, come with an I, right?
Yeah.
So how do you, there's a standard form for everything. So how do you write your imaginary number as? You write it as Z, that's the imaginary number, is equal to X plus YI. And this whole thing will be called as the complex number, right? In this, the X will be the real part and the one which contains I will be the imaginary
part.
Okay, so the real part is X and the imaginary part is Y. All right.
Okay.
Now, if I have to find, there are certain terms we are learning, right? There are certain terms we are learning.
Yeah.
Before we do that, can I write a number which is 3 in this form? In this form. Can I write the number 3 in this form? How I can write it as? Can I write it as 3 plus 0i, where 3 is the real part and 0 is the imaginary part. That is y. Can I write it like that?
Yeah, miss. Just one sec.
Yeah, yes.
Yeah, miss, you can continue.
Did you get this? So I
Yeah.
can write any real number also in the form of complex number. Just that the imaginary part is 0.
Yeah.
Clear? Clear?
Yeah.
Now we come to another question. Okay. So the question now asks you to find the conjugate of this imaginary number. So if Z is the number, is the imaginary number, Z with a bar is a conjugate. What is it?
Conjugate.
Z with a bar. What does it mean? If Z is X plus yi, where X is the real and Y is the imaginary part, then the conjugate would become
X minus
X
yi.
minus yi. Okay, X minus yi. Did you understand this?
Yes.
These two. So what is the conjugate of X plus iy? It's X minus iy or yi. It's the same thing. All right.
Yeah.
Okay. Now, let's take an example. Z is 3 plus 4i. What is the real part in this?
3.
3. Okay. What is the imaginary part?
Plus 4. I mean 4.
4. What will be the conjugate?
3 minus 4i.
Perfect. Excellent. Okay. Now, I'm going to hide the answers. I want to tell me a few things here. Real part?
For the first one?
Now,
2.
Real is 2. Okay. Then imaginary?
3.
Conjugate?
2 minus 3i.
Real, second for this one. Now,
2.
2.
Imaginary is minus 3.
Minus 3. Conjugate?
2 plus 3i.
Very good. Third one.
Real part is minus 2. Imaginary part is 3. And conjugate is minus 2 minus 3i.
Fourth one.
Real part is minus 2. Imaginary part is minus 3. And the conjugate is minus 2 plus 3i.
Minus 2 plus 3i. Okay. Next, go with this one now. Here, this one.
Real part will be 0.
Very good.
Imaginary part is 3.
Right.
Conjugate will be minus 3i.
Minus 3i. So we've understood this whole thing, right?
Yeah.
No confusions.
Mhm.
Very good. Hi, Arsh.
Hi, miss. Sorry, I'm late.
Haan,
Shabash.
you've missed the basics.
Miss, is this imaginary numbers?
Yes, these are complex numbers.
Miss, can you explain it to me?
So we have come quite, you're half an hour late, Ash.
Yeah, miss, I know.
So just listen to this. This is just a kind of a, little bit of understanding class. I'm going to repeat this, but just listen to it and switch on the camera.
Yeah.
Okay. Just understand going forward. Now just need to understand that if something is written in this form, Arsh, 2 plus 3i, pehle switch on karo camera ko.
Huh.
So if something is written in this form, this is the real part. This number is the imaginary part, which has an I with it. Abhi itna yaad rakho, okay? Because that's what we are going to use forward. All right. Now we reach the next point. Now we have understood what is a complex number. We've understood what is the real and imaginary part of a complex number. We've understood what is a conjugate of a complex number. Now we are learning the modulus of a conjugate, modulus of a complex number. Okay.
Okay.
Modulus is something what you learn as a Pythagoras theorem. It's something similar. What you do in Pythagoras theorem, you take the
A square plus B square.
if
Equals
this
C
is
square.
right. So this part, the base part, if I am doing this, if suppose this is C, this is B, and this is A, the B is nothing but the X value. Sorry, A is nothing but the X value and B is nothing but the Y value, right? And
Yeah, it's
what you
basically the
get
same.
is this C, right?
Yeah.
Exactly, that's what we are going to do as the when we are finding the modulus of these numbers, right? So Z is equal to X plus YI, all right? So what is the modulus? How do you, the symbol for modulus will be like this, like absolute numbers, you remember?
No.
Yeah.
Absolute numbers, you remember? No, you don't?
No, miss.
I remember.
Absolute numbers kya hote the? When you put anything -3 in these two bars,
Oh, that's
you always
modulus.
get a positive number outside, right? That's absolute number.
Yeah.
So you put those bars here. In between those bars, you put the Z. Because we always want a positive number for this. That's why. All right. So symbol is understood. Symbol for modulus is Z within the bars.
Yeah,
and
absolute numbers is like the non-negative value.
Non-negative numbers. Absolutely. So, and here we
So
want
like even if it's a positive number, the absolute number will be
so
the same.
you remember the bars that you used to put, that those were not bracket, those were like bars. In the same way, here also we put bars for modulus. Okay. And what is the answer? The real part square and the imaginary part square, leaving the y, leaving the I won't include here. Okay. So suppose I have this question, Arsh, batana zara, Z is equal to 2 plus 3i. What is the real part, Arsh?
Modulus Z equals
Real part बताओ मुझे, real part क्या है इसमें से? In this question, 2 plus 3i में real part क्या है?
2.
2. And what is the imaginary part?
3i.
So you imaginary part, you will always say 3. 3 is the imaginary part. Okay. So when I'm finding the
I was
modulus,
always there.
I will always be there. That's why that part is imaginary. Okay. So finding the modulus will be, you put that symbol in the bar. And Shreyash, can you tell me how do I now find the value?
So then it become a root of x square plus y square, which equals to root of 2 square plus 3 square, which is
Excellent.
just root 13.
Which is equal to 4 plus 9, which is, in this case, it's under root of 13. So the modulus of this complex number is under root of 13. Understood? Understood? Now, can you tell me what is the conjugate of this number?
Yeah,
What is
miss.
the conjugate of this number? For
Yeah,
this number?
miss.
Miss, what's a conjugate?
Conjugate, I'll tell you. Let Ashresh answer.
So the-
karo.
Yeah,
is the
conjugate would be 2 minus 3i.
So all you need to do is change the sign here, Ash. So if it is 2 plus 3i, you change it to 2 minus 3i. You always reverse that sign. Agar minus hoga, to you put a plus. Agar plus hoga, to you put a minus. That's how you get the conjugate. Okay. All right. So now we have these numbers. Let's figure out what is the modulus of these. It will be x square plus y square under root. For the second one, Shreyash,
X square
what is the
minus y
conjugate?
square.
It's also x square. Then there's a
Minus.
plus sign and you put minus y square,
Yeah.
right?
Oh,
For the
okay, yeah, because it has to be the whole, because the plus
Right.
is
So this is the first one. This
y
is
is
the second.
minus y. It's not
Let's
like
do
you
the
put
third
in the
one.
same.
For the
Wait,
third
wait.
one.
But this on top means conjugate.
If this is on top, that's conjugate. If it is like this, it is modulus.
Yeah.
Yeah, so this
for
one will
the
be
third one.
minus x whole square minus y whole
Plus
square plus
minus
minus y whole square
Okay, which you eventually it becomes x square plus y square.
plus y square. Yeah, it
What
doesn't
about
make a
the fourth one?
difference.
What about the fourth one?
Minus x whole square plus y
Minus
square.
x whole square plus y square under root. Eventually, even this becomes x square plus y square. So what is my observation out of all of these four things? What is the modulus?
It won't matter if it's negative, it'll be the
It
same.
won't matter if it is negative. The modulus is always the same. Plus minus
Because
signs.
without using complex numbers, you can't have a negative number as a square.
Excellent.
or like-
Excellent. So this part is understood. Modulus is understood, and if this is an extension of modulus. This is also understood. Ash,
Yes,
ye
ma'am.
samjhaya?
हाँ
got it,
मैम.
Ash? Huh? That doesn't matter what the modulus is, what the values are. Agar number same hai with the plus minus sign, because of that square, modulus is coming out to be the same. Clear? Clear?
Yeah.
Okay. Now,
Miss, I sent you 2 things on WhatsApp. So, Miss, these are a few questions on linear equations that I have to do, and I'm having a hard time with the 11th one.
okay, we'll do that later.
Yeah.
Okay. Now, coming to this, so if I have this question, 4 of these, what will be the final answer? For all of them, it will be 5 only.
Yeah, they all have the same modulus.
Because if I just find out the first one, 3 square plus 4 square under root, I'll get 9 plus 16 under root, which is
Root 25, which is
5. And since I only need the positive answer because it is modulus,
modulus.
so I will not write plus minus. I will only write 5. Otherwise, root 25 has 2 answers, plus and minus. But what am I supposed to write here? Only plus 5. Got it?
Yeah.
Clear? Right? Now we come to the next topic, that is equality. So 2 complex numbers and they are equal. Understood? So 2 complex numbers are equal if they have equal real parts and equal imaginary parts. So, which means if I say Z1 is equal to X1 plus Y1I and Z2 is equal to X2 plus Y2I, then I conclude that X1 is equal to X2 and Y1 is equal to Y2. Is my point clear?
Yes.
Right? So using these, we will have questions on simultaneous equations. Okay? You remember what are simultaneous equations?
Yeah.
Yeah.
Okay, so we are going to use simultaneous equations here. Let's see how. Question given to you is Z1 is 3 plus 4i and Z2 is equal to A plus 3b minus 2i. Find AB if Z1 is equal to Z2. So they have already told you that Z1 is equal to Z2. Now you have to tell us what is the parts which I should write as equal. Tell me. This is the real part.
Yeah.
Here, this is the real part,
Yeah.
right? Right? Yes or no?
Yes.
Louder,
Yeah.
right?
Yes.
Equate them. Tell and give me the answer if you're able to figure out.
3 and 2.
Can you find it?
They
So,
would equal to 3.
Miss, 3
so-
minus 2 is the imaginary part.
3b minus 2 is the imaginary part because that entire thing has I.
Yeah.
Okay.
So it'll be 2. B will be 2,
And A is equal to
3.
A is equal to 3. Ash, did you understand this part?
So Miss, I means imaginary.
I means imaginary. That part is imaginary. Okay.
So 4i doesn't mean 4 times I. It means
No.
4 imaginary.
No, 4 times I, it means 4 times I only, and that is the imaginary part.
So does I have a value?
I has a value. I is equal to, what is it, Shreyash? I is equal to
Root of negative number.
root of minus 1.
Root of minus
Oh,
1.
okay.
Now going forward, root of minus 1 is always considered as I. Okay. Now coming back. So here, this is the real part, and here this is the real part. So can I say that 3 is equal to A? So I got the value of A,
Yes.
and this one is the imaginary part, and this is the imaginary part. So can I
It'll be
say
2
4 is equal to 3B minus 2?
minus 2.
This minus 2 goes here. It becomes 6 is equal to 3B, and that's how,
Yeah.
Shreyash, your answer is absolutely correct. B is
2.
equal to 2. Clear?
Yeah.
Ash, samajh aaya beta?
Oh,
I know you must be not be able to understanding. You won't be able to understand few things. Thoda confusing lagega because half the class
yeah,
was
but
missed,
Miss, I'm
no?
catching
So,
on. Like,
yeah, it's not very complex. It's complex numbers, but complex numbers is not complex at all.
yes, Miss.
I feel like they just
Okay.
use that as a way to
Alright.
describe numbers that can't be like said without variables or whatever.
Yes. And once you understand the concept, it might look very intimidating. Pata nahi kya hai, but it is easy. It's an easy topic. Okay. Now suppose like we you know how we when we was kids. So 1, 2, 3, 4 pehle sikha. 1, 2, 3, 4 सीखने के बाद we learned how to add those numbers, multiply them, subtract them, divide them. यही सब सीखा हमने, right?
Yeah.
So we are learning a new number system. We learned the complex numbers, कैसे लिखा जाता है, क्या होता है. Now we are learning the operations. Okay. So what are the operations? Addition, subtraction, multiplication, division. 4 operations, right? So we'll first learn how to add them. Very easy. One thing that you need to keep in mind is under root of minus 1 is I. And if I square both the sides, what will happen? Under root of minus 1 square is equal to I square.
I square.
Which means I square is equal to what? Just
Minus
a minus.
Minus 1.
बस अब इसको ध्यान में रखना है. Keep that in mind. ठीक है? Now, what we are going to do is we'll learn how to add these complex numbers. Okay? Add करने में it's very simple. Exactly like what you do with variables.
Yeah,
Other
just with the
मेरे
like
पास-
terms.
Exactly. You add the like terms only, right? So if I have 7x plus 3y, can I add them? Can I add them?
No.
Can I say it's
No.
10? No, it's not. So, but if I have 7x plus 3y plus 2x plus 8y. So what will I do?
Add the like.
I will add the like
Add the
term.
like.
दोनों को add कर देंगे. So 7x plus 2y is 9x and 3y
Plus
plus 8y
11x.
is 11y, right?
11y,
Exactly the same concept we'll do here. Just that यहाँ पे variables x और y नहीं, यहाँ पे real and imaginary parts हैं. Correct? So if I have 7 plus 4i and 2 plus 3i, we will add, if I have to do this, if I have to add them z plus w, then I will add the real parts. So real part add करके बताओ answer क्या होगा?
9.
9. And we'll add the imaginary parts. What's the answer?
7i.
Plus 7i. That's it. My answer is done. Now you added them. Now tell me the conjugate of this,
Conjugate of the whole thing?
of this answer.
9 minus
9
7.
So
Yeah.
if I ask you z plus w conjugate, is it so complex? No,
No.
it's as simple. It's just 9 minus 7i. Now I'll ask you, what is this? It looks complex, but answer क्या होगा इसका?
9 plus 7i, right?
So 81 plus 49 whole root.
So this is what modulus, huh? This is modulus. Modulus में क्या करते थे?
Yeah.
No, root x square.
Root 130.
Right. 9 square plus 7 square.
7.
Yeah.
Right. Root करते थे हम, right? Absolutely. So which is 81
130.
plus, how much is it? 49.
49.
Under root
Yeah.
of this is equal to how much?
130.
One
Under root of 130.
root को 130 and that's it, we are done. Difficulty hai koi? Any problem in this?
No, miss.
Oh, we have gone so ahead. Very nice. Very impressed. Ash, any problem in understanding all of this?
Miss, I got
Easy.
that.
Very easy. Okay. Now we are going to do the same thing with subtraction. Okay. So हमको क्या करना है? Again, we have to pick up the like terms. What are the like terms? क्या
Real
like terms?
and imaginary.
Real and imaginary. So same question. Now you have to subtract them. But now you're subtracting, right? So it is 7 plus 4i minus 2 plus 3i. Open the bracket. What do you get? 7 plus 4i minus 2 minus 3i, right? So operate on these two and operate on these two and give me the answer.
So be
5 minus
minus 5,
I.
5 plus I.
5 and 4i minus 3i is 5 plus i. Absolutely. So I got the answer for. अब इसका conjugate निकल जाएगा.
5 minus I.
5 minus I.
इसका modulus निकल जाएगा.
25.
It just be 5.
Perfect.
It just be 5 the modulus.
Yeah.
Because you have to find do the under root also, right? इसलिए.
Yeah.
Clear? ठीक है. All right. Now, why did I ask you to keep this in mind? Because now we are going to multiply. It's exactly the same thing as you multiply two brackets. Let's first revise
Oh.
that, right?
So you could just replace them with
X plus 3
A and B and then just use the same formula.
x minus 2y. चलो, अब इसको बताओ जरा कैसे हम multiply करते थे?
You can
A
just
times C plus A times D plus A times plus B times C plus B times D.
And if there's a
Yeah.
negative sign, then
If there's negative, then minus on that term.
that term. ठीक है?
yeah,
So you would do 2x into 3x,
6x.
which is 6x. So should I just straight away write the answers now? 6x. Then 2x into minus 2y, which is, I'll have to put a negative sign.
Minus, yeah,
4
minus
What
4xy.
xy. So now I don't need negative like terms to multiply, right? ऐसा कुछ नहीं है.
Yeah.
I can multiply two unlike terms clearly, right? Okay. Then 3y and 3x,
9xy plus
9xy,
9xy
and 3y and minus 2y
minus 6y
minus 6y square.
square. Yeah,
Square,
because
right?
it's 2y.
Here also there is a square, by the way, huh?
Oh yeah,
2x
6x square.
Right. So now इसपे I can't do anything with 6x square, but can I operate on these
5x.
two?
Yeah.
Huh?
So
What is
it
that?
just be 5xy.
So plus 5xy. Arsh, you said something?
5xy.
5xy. So 6x square plus 5xy minus 6y square. This part is clear?
Yes,
Now
ma'am.
exactly the same logic will apply here. ठीक है? Just that यहाँ पर हमारे पास क्या है? We don't have these x and y variables. We have
But you put
real and imaginary.
real
Let's
and
multiply.
imaginary.
Let's multiply. So this is your value here. These are the brackets. So 7, 2 plus 3i plus
Yeah.
4i, 2 plus 3i. That's how you multiply them, right?
Yeah.
7 to 2 is 14.
14
7
plus 21i.
I. 4 into 2 is 8i.
I.
And 4 into 3 is
12.
12i square.
12i square. Okay. Now, can I operate on these two? Can I
Yes.
operate?
You leave it
29i.
I square as -1 and make that -12.
हाँ वो करते हैं बट पहले हम इन दोनों को ऑपरेट कर लें 21 एंड 8 को 21 एंड 8 कितना आ जाएगा आंसर हमारा
29.
प्लस
29i.
29i अब आ जाओ i स्क्वायर पे व्हाट डिड आई टेल यू i स्क्वायर इज व्हाट
Minus 12.
सो कैन आई राइट इट
Minus
एज
1.
12 into
Yeah.
-1 which is
Yeah.
-12
So it's just 2 plus 29i.
absolutely -12 so 2 plus 29i that's my final answer clear
Yeah.
easy
Yeah.
any
Yeah.
confusion here no confusions
No.
okay perfect
No. Miss.
Ash, समझ आ रहा है बेटा?
Miss.
Great. Now, what about division now? Division में क्या करें? Okay. Division को just like the way you do surds में हमने एक चीज सीखी थी जिसको हमने बोला था it's called as the process of rationalizing. Do you remember that? It's very similar to that process. Surds में हमने चीज सीखी थी rationalizing. What it means is, suppose I'm going to revise that concept and then come back to this one. Okay. Suppose, why is my G not going away? Suppose I have 2 upon root 3. So when I was doing surds, based on that, we learned that root 3 cannot be in the denominator. I can't have a root
To the power -1.
Right. So abhi minus तो नहीं है. I'm just talking about surds, what we learned last year.
Yeah.
Okay. So how do I rationalize this? So you remember we used to
You
multiply
multiply by the denominator.
and divide by the same number. Remember?
Yeah.
Arsh, yaad aa raha hai?
Multiply both terms by the denominator.
By the same, yeah. So multiply and divide. Why are we doing this? Because root 3 upon root 3, if you cancel, it's 1. So you're not
Yeah.
changing the meaning of the question. Okay? Agar yaad nahi hai, that's why I'm revising this. Okay?
So, Miss,
So what are we-
it wouldn't be rationalized if I took root 3 to the power -1 and just put the final answer as 2 root 3 power -1.
That we only do when there is a variable. But if I have a root 3 in the denominator, we cannot have a root 3 in the denominator because this is an irrational number and I have to rationalize it,
Okay.
make it rational. So there's a process where we used to multiply and divide with the same thing.
So you
Just getting a whole number.
Yeah. So that my
You just have to
denominator,
make the denominator a whole number.
yeah, I have to make the denominator as a whole number, a real number, right? So a rational number, sorry. So what did I do? Multiply with this, right?
Yeah.
Right. So
Yeah.
this becomes, I still have a root 3,
Root
but now
3.
it is in the numerator, which is okay.
Yeah, which is fine.
Right? Which is fine.
Over 3.
Upon root 3 into root 3 is nothing but it's root 3 whole square. So
Yeah.
this and this get cancelled
Yeah.
out. So I'm just left with a 3, right? That is what I get here. This is clear? This part is clear?
Yeah.
Now, what if my question is 2 upon 2 minus root 3? Let's do 1 upon 2 minus root 3. हाँ. अभी क्या करें?
So, Miss, you'll take times 2 minus root 3 upon 2 minus root 3.
So here, और सोचो, कुछ ठीक बोला आपने, कुछ में एक small change करना है. The small change would be, what you just said is, I will multiply with this. This is what you said?
Yeah.
Yeah.
अच्छा, इसको करके देखो जरा, आता है क्या? नीचे rational number आता है? Just think about this. It becomes an identity, a minus b whole square. If you multiply this, numerator would become this, and the denominator becomes 2 minus root 3 whole square. And if I apply this, I'm doing it on the side. I'm just doing it on the side. Just have a look. It becomes
Minus
a
1.
square
Oh no.
plus
2
b square minus 2ab.
A.
This becomes 4. This becomes 3. But I could not get rid of this root 3 still.
Yeah.
I get
Yeah.
7 minus 4 root 3. So this did not solve my purpose. So there's something wrong here. I need to do something else. I tried to make it a rational number, but now I'm again getting an irrational number in the denominator. So there's a small change. Keep the number the same, but here you put a plus sign.
Miss, is that allowed? Like, won't that change?
Is it changing the meaning now? Think about
No,
it.
it's still equal to 1.
It's
No.
still equal to 1, right?
Yeah.
Now let's see, why am I doing this? Let's compare.
But then, Miss, you could take any number.
Now, no, I have to take the same thing. Now see, it becomes an
Because then
identity.
otherwise the root wouldn't become a whole number.
Yeah. Isn't it somewhat like this identity which used to be a square minus b square,
Yeah.
right?
Yeah.
So if I put it here, what is my a? 2 square minus
Minus
root 3 square,
3 square.
right? So I get 4 minus 3, which is 1,
1.
right? So ab kya hua? Are you getting it? This Arsh? Which
Yeah.
identity
Yeah.
did it become? It became a minus b into a plus b, which is
So the
a
thing is just 2 plus root 3.
Yes. So what am I doing here? Am I not taking the conjugate here?
You are.
Exactly. So now you understand what are we going to do with imaginary numbers,
Oh, okay. Yeah, I see.
right? So now see, It's 2 plus root 3 upon, you understand this will become 4 and this will become 3. So 4 minus 3 is 1. So see, my final answer is 2 plus root 3 only in this case, in this particular case that we had taken, Abhi, right?
Yeah.
And now we are going to do the same thing
And
with
you'll
our,
always have to take the conjugate because I would be a minus.
right, because
Yeah.
I don't want an extra 2ab there in the identity, right?
Yeah.
That's
So
why.
always take the number that you have, the denominator which has an imaginary number, and
Right.
then multiply that by the conjugate of this imaginary number upon the conjugate of this imaginary number.
Superb, superb, excellent. Okay, so you have this is what you're supposed to divide. 7 plus 4i divided by 2 plus 3i. So what are we doing? We are taking the conjugate, right? And we are multiplying. So in the numerator, you multiplied just the way what you learned when we
Yeah.
learned how to multiply. But in the denominator, it becomes, what does it become? 2
2
square.
minus 3.
Minus.
Plus or minus 3 whole square.
So minus 3i square, है ना? ये बन गया, which is 2 का square is 4 minus 9i square,
Yeah, minus 9 plus 9.
right?
Yeah.
So it becomes 4.
Okay, I can just do that as well.
Right. We have to take that I also, right? So this becomes 4 plus 9, so 13 aa gaya. My denominator is without an imaginary thing right here. Ab numerator you multiply the way you learned. And then you will see, okay, after multiplying, you'll see that this becomes 26 minus 13i. And denominator is 13. Can we divide them?
Yeah.
Yes.
And after dividing, what do we get?
2 minus I.
2 minus I. That's your final answer. How do we get that? 26
Divide
upon
them.
13
2
minus 13i upon 13. So this becomes
minus
2.
I.
This becomes I. 2 minus I. That's the final answer. Right? Clear?
Yeah.
So what's the division of these two? The division of these two is 2 minus I. Are we clear?
Okay.
Yeah.
All right. All right. So this is where I am going to stop today. All right. And let me give you some work. This is your work.
Okay. So just do the division, just do each thing for.
Each one.
Okay.
each one.
Yeah.
Okay. Is it difficult?
No, miss.
So just note this down and try doing it. Note it down. Take 5 minutes.
I took a screenshot.
Because okay, and start doing it. However much you're able to do, give me the answers.
Okay.
Yeah, miss, even I took a screenshot.
Okay, start doing it right away.
Okay, miss.
Miss, can you look at the things I sent on WhatsApp?
हाँ, just a minute, huh? Let me just finish this off. और आप करो अर्श इसको. Stay back for 5 minutes, I'll tell you.
Miss, is D 10 upon 17?
10 upon 17. There's more to it.
I'm doing it right now.
What more to it, Miss?
There must be an imaginary part also.
No, Miss, I because imaginary was I square, so it turned to -1.
Is it only I square? Think about it.
For D, I got 10 plus 11i over 17.
10 plus I, 11
10
I.
plus over 17.
That's correct. That's correct. Ash, I need to check yours. What about?
Because you get an imaginary number in the numerator, but not in the denominator.
Not in the denominator, right?
Wait, so I got, Shreyash, did you get 12 plus 2I square in the numerator?
No,
what
I got
about-
10 plus 11i.
Um,
Because you have to do 3
Ash, I
plus
think
y
you
into
missed
4
the
plus
I
I.
wala part. 3
Yeah.
multiplied by 4, then 3 multiplied by I also.
You forgot to
right?
you forgot to calculate the I
yeah,
in the numerator, and you forgot to I square.
Yeah. So you only did 3 into 4, and then you straight away did 2I into I think.
yeah.
Yeah.
I think you forgot to do 3 into I and 2I into 4.
Yeah.
Yeah, Miss, I forgot that.
Yes. So you need to do that. Shreyash, give me the answer for C. C, did you
For
do?
C, I got 14 plus 5i.
Okay. And B,
Minus 1 plus 3i.
excellent. And A,
4 minus I.
A,
4 minus I.
4 plus 3 is 7. And 2I.
Oh, wait, no. Miss, oh, I put the wrong thing for A. Oh, one sec.
Miss, for CI,
It's 7 plus I.
7 plus I is correct. Okay.
Yeah,
Yes.
I put 4 instead of.
Miss, for CI got 2I square plus 11I plus 12.
You can simplify the 2i square by putting it as plus 2, because I square is minus 1, and then you add it to 12. So it becomes 14 plus 5i.
Yes. Shreyash, yours is all correct. So that's all for today. I hope you could understand everything. It's a completely new perspective of number system today. Did you understand everything clearly?
Yeah, miss.
Okay, great. So that's it for complex numbers. Now